For this lesson, I want to talk about tubing and piping. Just about everything in the HVAC trade is either carrying liquid or gas from one location, carrying liquid and gas to another location. Everything we do requires tubing and piping. There's a couple different types of copper tubing. First, we're going to talk about ACR, air conditioning and refrigeration tubing. It normally it's a soft copper tubing and comes in 25 or 50-foot rolls. The pipe diameter sizes are determined by the outside diameter, or OD. Be very careful when you're going into a store or any place where you're picking this stuff up, because it does need to be OD, ACR tubing. These are some of the rolls. The smaller one is 1/4 inch, then you might have 3/8, and then you might have 1/2 or 5/16. It will always say on the outside of the package, but it's not always giving you that size in outer diameter. Line sets are ACR tubing that's purchased with quick disconnects on the end. Sometimes they're a bundle of thicker and thinner tubing. The thicker side has insulation on it or Armaflex. This is an example of the line set, and you can actually see the quick disconnects on the end of the tubing. The suction side, or the low pressure side, because it sweats and it's cold, is covered with insulation. Pipe sizes are determined with rigid copper piping by the inside diameter. It's approximately 1/8 of an inch smaller than the outer diameter of ACR tubing. Couple different types of rigid copper pipe. Type K pipe, it's heavy duty. It's used where severe corrosion is possible. Type L, it's most commonly used for boiler piping, refrigerant piping, and it's currently what's required per code in domestic water and baseboard. The Type M and DWV are not typically used in HVAC. Type M is usually used for underground water lines. DWV is used for waste lines. The type of the copper pipe will be stamped or written on the side of the pipe. Make sure you never sand it all off, and make sure it's always visible for a building inspector if you're doing installation. A couple processes we deal with copper pipe is annealing. The process of heat treating a hard copper pipe to make it more flexible. You heat the pipe up, you slowly bend it while it's hot, and then you heat it again and it sets it. Typical outer diameter sizes of pipe are 1/4 inch, 5/16, 3/8, 1/2 inch, 5/8, 3/4, 7/8, and 1 1/8. The difference again between the two is usually 1/8 inch. So 1/2 inch inner diameter, take it to outer diameter, add 1/8. Find a common denominator. So it's 4/8 plus 1/8 is 5/8. 1/2 inch ACR tubing. Okay, again, outer diameter. So again, be careful with the pipe sizing. Couple tools you're going to use over the course of your years in the trade. Tubing cutters. They're equipped with a small reamer and a flare. Imp cutters. It's used for tight areas where the larger cutter will not fit. And a tubing bender is used to bend the ACR copper or annealed copper pipe. This is an example of the tubing cutter, the larger one. You see the wheels on the bottom and the cutting wheel. The handle, as you screw it down, it pushes pressure onto the cutting wheel, which in turn pushes it through the copper pipe. Now, you have to be very careful that you don't create flat spots on the pipe, so this needs to be constantly moving around the pipe as you're putting pressure onto it. Once you're done cutting the copper pipe, you remount the inside of it. In other words, get the loose burrs out. Don't take too much of the copper away because it will become weak. Now, the tubing bender can be a spring type or a lever type. In most cases of hard tubing, fittings are used to make the turns. Swag tool is used to make a fitting when a coupling is not available. It actually stretches the copper. A flare tool creates an opening on one end of the soft copper pipe to allow a connection to be threaded onto a brass fitting. This is an example of a tubing bender. You see it has marks on the side of it. You can bend at 0 degrees, 45 degrees, and 90 degrees. You can bend it either right or left, and it all has a starting point. A flare block is used to hold the pipe steady while flaring and swagging. Going to have a torch, some type of heat source so that you can braze and solder pipes. Propane torches are used normally to make copper connections. Acetylene types, they're the most commonly used in the field. They give more heat. They're used for both brazing and soldering. They come with either a B tank or an MC tank. The B tank is larger, an MC tank will fit into your tool bag. This is an example of a propane torch. Handheld, very light, very great for soldering pipes in basements or tight spaces. Does not put off enough heat to braze. Acetylene type, again, comes on a tank. It's heavier, but it does give a little bit of better heat. It can be both used to braze and solder. The torch tip automatically mixes oxygen with the acetylene gas to provide the proper flame size. Oxy-Acetylene torches come equipped with separate oxygen tanks. The oxygen can be manually adjusted to change the flame type and the temperature. This is an example of the Oxy-Acetylene torch. The acetylene's on the right, the oxygen tank's on the left. They get very, very hot, and you can actually burn through pipe and metal if they're not adjusted properly. One of the types of ways to connect metal is soldering. Solder requires very little heat to flow, usually less than 800 degrees. 95.5 solder is 95% tin, 5% alloy. All copper pipe fittings must be soldered, must be cleaned by a sand cloth and or brushes. In other words, they have to be clean. You've got to get whatever dirt and chemicals and oil that the factory puts on them before they're shipped off of them, or the solder will not flow. A special jelly-like soldering paste called flux must be applied as well. All the solder will not flow around the fitting without the flux. It actually provides some of the capillary action to pull it in. All lines in an R22 or refrigeration system except for the compressor discharge line may be soldered. All lines on a 410A system may not be soldered because of the higher pressures. The excessive heat of some discharge lines can cause the solder to melt and create a refrigerant leak. So, with soldering, what you're doing is you're using your base metal. You have one pipe inside the other. You're using some filler metal called solder, and as you heat that base metal up, it pulls the solder into the joint, and when it cools, it creates a hard coating and joins the two metals together. Another type of filler metal is brazing rod. It uses copper alloys with percentage of silver between 15 and 60%. It requires much higher flame temperatures to flow correctly, above 800 degrees. In most cases, as long as you're using the same metal, flux is not required to braze a joint. When brazing copper to steel or copper to brass, a special flux paste must be used to allow for the filler metal to flow. An example of this capillary action could be a tube in a glass, a straw, as the straw will actually pull the water up into it. Well, take this with metals. We have two base metals. We have a small gap in between them. We heat the metals up. The filler metal melts and actually gets pulled into the base metal through capillary action. When we're not soldering, or even when we're soldering, we use some different types of fittings. A coupling, straightforward, connects two pipes of the same diameter. A reducer, it's a coupling that connects two pipes of a different diameter. An elbow has a 90 or 45 degree turn and is used to make a turn in a piping circuit. A T is a coupling with a third access port, and it looks just like a T. One pipe goes in from each side. An adapter is threaded on one side and has a sweat or solder connection on the other. It allows you to screw a copper pipe onto something. Then there's some brass fittings we use. A flare nut. It attaches to a threaded brass fitting after a copper flare has been made. Flare by flare union. Both sides allow a flare nut to be installed. Flare by NPT union. One side uses a flare connection and the other side uses nominal pipe thread for a plumbing connection.